Hi guys, welcome to a new video on differentiation paper 2 under math studies. In this video I shall tackle problems of difficulty level 3 and I shall focus on problems that require you to carry out the F double dash test of maximum and minimum points. I shall solve the two questions on the screen and I shall begin the first question shortly. I shall now solve paper 2 November 2002 question 8I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in AI you are required to find f dash of x given that f of x is 2x to the power of 3 minus 3x squared minus 12x plus 5, rewritten in black right there. So this is simple differentiation and there is your derivative function. In I, you are required to find the gradient of the curve f of x when x equals 3. So when x equals 3, the gradient of the curve shall be 24, and the way I've obtained that is by substituting 3 into f dash of x. Since the gradient function is given by f dash, I shall simply plug the required x value into the equation of f dash of x in order to get the gradient at x equals 3. So in question B, you are required to find the x coordinates of the points on the curve where the gradient is equal to negative 12. So here, this is different. In I was given x and required to find the gradient. In B, I am given the gradient and required to find the x. So I shall just solve the equation the other way around. The gradient itself is negative 12. Hence f dash equals negative 12. So I shall equate the red expression to negative 12. And there is some simple algebra that needs to be done. You get the values of x equals 0 and x equals 1. So if you're unaware of what algebraic techniques need to be used here, I have simply taken out 6x as a common factor from these two terms, and what remained was x minus 1 inside the brackets. If two terms multiplied by each other equal 0, then I can solve each one separately. So 6x equals 0 and x minus 1 equals 0. Hence, x equals 0 or 1. There are your final answers, right there and right there. In C, I'm required to calculate the x coordinates of the local maximum and minimum points. Now this is important. You should know that the local maximum and minimum points are what we call stationary points or turning points. And the slope of these points is always 0. So in order to get the x coordinates of both, I just need to set f dash of x to 0. I need to solve for x. So this is what I've done. 6x squared minus 6x minus 12 equals 0. You can either use factorization or write it down on your GDC and find the zeros. Whichever technique you use, you shall find that x equals 2 and x equals negative 1. So which of these is the maximum and which of these is the minimum? There is a nice way to do that, to check this out, using the f double dash. What is the f double dash? The f double dash is the derivative of the derivative. So I shall differentiate this function again. Remember, this is f dash of x obtained by differentiating f of x. So to get f double dash, I shall differentiate f dash. This gives me 12x minus 6. The differentiation of 6x squared minus 6x minus 12 gives me 12x minus 6. So this is my second derivative. I shall use this second derivative as a test to check which of these is a maximum and which of these is a minimum. So I shall plug each of the x values into f double dash. If the answer is positive, then this means there is a minimum point. If the answer is negative, this means that we have a maximum point. So when x equals 2, f double dash equals 12 times 2 minus 6, which is 18. So when x equals 2, f double dash is positive. Hence, there is a minimum point at x equals 2. When x equals negative 1, I've evaluated f double dash to be negative 18. So when x equals negative 1, f double dash is negative. Hence, there is a maximum point. You can always draw the function on the GDC and check where the minimum and the maximum are. But in case they ask you to show or to prove something like this is the easiest way to do so. You get f double dash and you test whether it is positive or negative. But bear in mind that your intuition will tell you that positive gives us maximum and negative gives us minimum. No, this is not the case. If the answer is positive, the concavity is positive, so the point is at the bottom of the curve. It's a smiling curve and the point is at the bottom. So it's a minimum point. If f double dash is negative, the concavity is negative or downwards, so it's a frowning curve and the stationary point is a maximum. It's on top of the curve. And we have explained this in paper 1 videos on math studies differentiation as well, so you can check them out and you can check why the minimum point has positive concavity and the maximum point has negative concavity. In double I, you are required to find the coordinates of the local minimum. You can do so using the GDC, or you can simply plug x equals 2 into the function, the original function, which is right there in black, and this shall give you negative 15. Finally, in question D, you are required to state for what values of x the function is increasing. So if f of x is increasing, then f dash of x is positive or greater than 0. So I shall simply solve this equation. However, instead of equal 0, I shall use greater than 0, and this is an inequality. So since the sign is greater than, the answer shall be greater than the bigger number or smaller than the smaller number. Excuse me. So either greater than 2 or less than negative 1. This is my answer. So even though we can solve all of this using the GDC, bear in mind that there are 6 marks for finding the local maximum and minimum points. So you cannot just find them using the GDC. And I'll just show you quickly how to do that. So I've written my function down on the GDC. I've set the windows using these numbers for your reference. There is how the function should look like. So I shall quickly press on second, calculate minimum point, provide a left bound, a right bound, and a guess. So the GDC tells me that the x value is 2. Whenever the GDC has 1.999, of course you immediately approximate to 2. And the y value is negative 15. These are the same answers that we got for CI and double I. But you cannot simply just tell the examiner, these are the answers from the GDC. You have to show workout. And they specifically request that you find the minimum and the maximum using calculus and equations and so on, not just off the GDC. So you have to learn the manual approach as well. And we can see that the function is in fact increasing before the maximum point and after the minimum point. So this is why we said that for x is less than negative 1 or for x is greater than 2. Take a minute to copy the answer down if you will. This concludes our question. I shall now solve paper 2 May 2003 question 8I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in question AI, we are required to find f dash of x, given that f of x is this function right there, x cubed minus 4x squared minus 3x plus 18. So there is your function and there is the derivative function. In double I, you are required to find the coordinates of the maximum and minimum points of the function. So maximum and minimum are points where f dash of x equals 0. Hence, I equate the green equation right there to 0. You can solve this either manually or using the GDC. Anyway, the values of x are 3 and negative 1 over 3. Now I need to determine which of these is a minimum and which of these is a maximum. I need to do this manually and then check my answer using the GDC because there are marks allotted for your manual work. So we said before in other videos that the maximum point is a point on a frowning curve. This right there is a maximum point. It's the maximum of the curve, so it's on the frowning part of the curve. So since it's on the frowning part, f double dash is negative. So a maximum point always exists when f double dash is negative. A minimum point is on the smiling part of the curve. Hence, a minimum point will always have a positive f double dash. Because f double dash, which is the derivative of the derivative, has to do with the concavity of the curve. So if the curve is smiling or upwards concave, then f double dash is positive, and this corresponds to a minimum point. Otherwise, if the curve is frowning or downwards concave, f double dash is negative, and this corresponds to a maximum point. So what I shall do is I shall obtain an expression for f double dash by differentiating this green function right there. So f double dash is 6x minus 8. And I shall then plug each x value to see whether f double dash is positive or negative. When x equals 3, f double dash is positive 10 or any positive value. Hence, this is a minimum point. When x equals negative 1 over 3, f double dash is negative. Hence, this is a maximum point. Hence, at x equals 3, we have a minimum, and at x equals negative 1 over 3, we have a maximum point. We can also use the GDC to check this out, but you have to do the manual work and then check your answer using the GDC. So let's take a look. So there is my equation of the curve corresponding to the original function in black on top of the page. There is my window in case you want it for reference. There is the graph of the function. Now to find the maximum point, I simply press second, trace, maximum. I provide a left bound and a right bound. Then a guess. So the maximum is negative 0.333 or just negative 1 over 3 and 18.5. And this corresponds to what we have written using the manual approach. Next, I repeat for minimum. So second, trace, find minimum point, provide a left bound, then a right bound, and then a guess. So the minimum point is at 3, 0, and this again corresponds to what we've written right there. So you can always use the GDC to check your answer if there are a lot of marks provided for getting the minimum and max. What I mean to say is, if there are a lot of marks, you have to do it manually and then use the GDC to check your answer. If there are only 1 or 2 marks, you can get the answer using the GDC automatically. and the wording of the question will differ. Either they will ask you to use the equation of f dash to find the minimum and the maximum, or they shall say calculate the minimum and the maximum. This, as well as a big number of marks, should force you to use the manual approach. So bear this in mind. Next, in question B, I'm required to find the values of A and B of f of x in this table below, and there is my A and there is my B. There is a nice calculator function to do that for you. Second, trace value, and you simply enter the x value. So the first x value is -2. So when x equals -2, y equals 0. Hence the value of A is 0. So to get the value of B, I shall repeat the procedure with x equals 0. Second, trace value x equal 0. And this tells me that the value of B is 18. So the value of A is 0 and the value of B is 18. Next, I'm required to sketch the function using the information in this table right there, and to label clearly. So there are your answers. As we said, A is 0 and B is 18 in the table, and in question C there is how your sketch should look like. And the marking scheme provides 1 mark for correct scales and labeled axes, and you have to use the domain that they gave you. You have 2 marks for placing the minimum and the maximum values correctly. So there is your maximum at x equals -1/3 and 18.5, and your minimum at 3, 0. And a mark for a smooth curve, which has to do with the quality of your drawing, and a mark for all the points plotted correctly. The gradient of the curve at any particular point varies. Within the interval -3 to 5, state all the intervals where the gradient is positive and negative. Negative and then positive. So we want to look at the curve and see where is the gradient negative and where is it positive. This has to do with whether the function is increasing or decreasing. So first of all, the gradient shall be negative when the function is decreasing. And the function is decreasing in this part right there. This part lies between the maximum and the minimum points. Hence, it lies between x equals -1/3, which is right there, and x equals 3, which is right there. So -1/3 less than x less than 3. And the gradient is positive when the function is increasing. So whenever x is less than 1/3, any of these points right there have a positive slope because the function is increasing. So x is less than -1/3, or x is greater than 3 at any point starting the minimum point, starting right after the minimum point, the function is increasing. Hence, for all this part of the graph, for this entire part of the graph, the gradient is positive. And this part corresponds to x greater than 3. So there are my answers. The gradient is positive when x is less than -1/3 and all the way to -3. So there is my first interval, or after 3 and all the way to 5. There is my second interval. And it is negative from -1/3 up until 3, any point in this region. So this concludes our question. Take a minute to write this down if you will. I hope you have found this easy to understand.